This lesson is the culmination of all of the chemical calculation content you could be asked in GCSE chemistry, grade 9, grade 10 chemistry if you're in the US. It brings together all of the formulas that would be used for molar calculations. So working out moles for solids, working out moles involving liquids / solutions, and then molar volumes for gases. If you look at this equation, we have, it's a really simple one. It's just an acid-base reaction, as you can see, an acid-carbonate reaction. But we have the solid state symbol, the aqueous for liquids, and gases, all in one equation. So I think at this point, it would be good to recap what the formulas are. So we have solids, liquids, and gases. And then for each state of matter, there is a formula. For solids, moles is equal to mass in grams over RFM. For liquids, moles equals C times V, concentration for C, V for volume. And then for gases, moles equals V divided by 24. Now for the liquids and gases formula, it's really important you remember the volume is always in decimeter cubed. That means if you were given the volume in centimeter cubed, you will have to convert from centimeter cubed to decimeter cubed if using those versions of the formulas that I've written there. 1,000 centimeter cubed is equal to 1 decimeter cubed. So if you turn in from centimeter cubed into decimeter cubed, you divide by 1,000. If you go in the other way, you times it by 1,000. Right, 3-point process. I've attached that below the video, but I have covered this entire method in another video. So please watch that if you haven't, because that is what I'm going to do to work out this question. So let's take a look. Number 1, find the volume in centimeter cubed of carbon dioxide released when 3.5 grams of copper carbonate dissolved in 65 centimeter cubed of nitric acid. So once the volume of carbon dioxide, so this is clearly a gas, released when 3.5 grams of copper carbonate, so that is a solid, is dissolved in acid. Now in the 3-point process, I stated that you will always be given, you'll be given information on one of the reactants, as in like quantities of the reactants, and you'll be told what is asked for in the question. So we want carbon dioxide, so I'm circling that, and we are given information on copper carbonate. So I've circled those two. Now you may be thinking, well, why haven't you circled nitric acid? Because we don't have enough information on nitric acid to work out the moles. But for copper carbonate, we do, okay? So there's only 2 things you circle. With that said, step 1, here we got to work out the moles of copper carbonate. So I'm going to use the solids formula. So moles is mass over RFM. So the mass is 3.5, and then the RFM is 63.5 for copper, plus 12 for carbon, plus 3 times 16 for oxygen is 48, gives us, so that is the moles of copper carbonate that is dissolved. The next thing is to work out the moles of carbon dioxide, and to do that we compare the molar ratio. So this is an easy one because you can see it is a 1-to-1 ratio of copper carbonate to carbon dioxide, so therefore the moles of CO2 is also 0.02834. Number 3, now if reading the 3-point process, it says work out what is asked for in the question. Well, it's asking us for the volume of carbon dioxide, so I'm going to use the volume formula for gases. Moles equals V over 24. Rearranging gives me V equals moles times 24. Remember, this answer comes out in decimeter cubed, so don't forget to times it by 1,000 at the end. So times in that previous moles by 24 gives me, if I times that by 1,000, that gives me a final answer of 680.2 centimeter cubed to 1 decimal place. So you can see in our first question, we used the solids formula and the gas formula at the same time. Number 2, what concentration of acid would be required for this reaction? So there's the giveaway. It's talking about concentration, acid, so that's the solutions formula, moles equals CV. So I need to rearrange to find C. So C equals moles divided by V. and we need to work out the moles of nitric acid. We have the volume, it's there, but we don't have the moles of it. So how can we get the moles of nitric acid? Well, if we go back to the equation, I can circle the nitric acid and I can see that the molar ratio of nitric acid to copper carbonate, hopefully you can see that's actually 1 to 2. So 1 copper carbonate reacts with 2 nitric acid. So I have the moles of copper carbonate from the previous question, just underlined it again there in green. So now I can work out the moles of nitric acid. So let's do that. Moles of nitric acid, HNO3, will be 2 times 0.02834. So again, notice I'm not rounding nothing up here. And that gives me, right, final step. Plug in that number along with the volume of nitric acid. So that's 0.05668 divided by the volume, which I've just circled again. That's in centimeter cubed. So don't forget, we need to turn that into decimeter cubed by dividing by 1,000. So 65 divided 1,000 gives me 0.065. Dividing that gives me a final answer of, so to 1 decimal place, that would be 0.9 moles per decimeter cubed. Right, I hope that was helpful. Please like and subscribe as it really helps the channel and keeps me making these videos. And thanks for watching.